Hello, everyone. It's time to tackle some wave example problems. Before we get to the examples, it's important to remember what our equations are. So I'm going to throw those up there. We've got our wave equation, velocity or wave speed equals frequency times wavelength. And we also have the period frequency relationship. So frequency is the inverse of period and vice versa. So here is example 1. You can go ahead and copy this into your notes. The lowest sound the human ear can detect has a frequency of 20 hertz. If this wave has a wavelength of 17.2 meters, what is the speed of the wave? So first up, we want to draw a little sketch here of our wave. Sound waves looks the same as all other types of waves, so there's our wave. Next up, we want to write our givens and unknowns. So if we read the problem, it says the human ear can detect a frequency of 20 hertz. So that's one of our givens, that's one of our numbers with a unit. So we're going to write down 20 hertz. And what is that given telling us? Well, it's telling us the frequency, right? Frequency is hertz, so that 20 hertz is our frequency. Next up, it says the wave has a wavelength of 17.2 meters. So we're going to write down that as one of our givens, 17.2 meters. What is that telling us? Well, it is telling us the wavelength, right? Wavelength is measured in meters, so that 17.2 meters is our wavelength. Remember, that's a Greek letter lambda. So what are we looking for in this problem? It's asking us what is the speed of the wave. So we're looking for wave speed, which is v. What is our v of our wave? So next up, since we have our givens and unknowns, now it's time to pick our equation that we're using. The equation we want to use out of these that were given is the wave equation, right? We have frequency, wavelength, and wave speed. So we want to use our wave equation. So that's wave speed is equal to frequency times our wavelength. Step 5, which would be to rearrange the equation. We don't have to do that because velocity is by itself on one side of the equation, so we're all good. We don't have to rearrange. So we can skip to step 6 and look at our units. We want to make sure the units all work out. So if we're looking for wave speed is measured in meters per second. So we want to make sure we're going to get the right unit from our equation, which I already talked about earlier in the last video. So our units for frequency are hertz, but they're also 1/seconds. Remember, a hertz is the same thing as a 1/seconds. So if we take our hertz or 1/seconds times our meters, we get meters per second, right? Because 1/seconds times a meter is a meter over a second. So the units are going to check out for us. Everything, it looks good. Next up is the last step, which is to solve. So now we're going to plug our numbers into our equation. So we're looking for wave speed. So V equals our frequency, which was 20 hertz. Instead of using hertz, I'm going to use that 1/seconds, right? Because I want to get the right unit for my velocity. So 21/seconds is going to be multiplied by my wavelength, which is 17.2 meters. If I plug that into my calculator on my phone, I get velocity is equal to 344 meters over seconds. And that is my answer. Remember, it's meters over seconds because we took that 1/seconds times our meters. And that's my answer. So that's example number 1.
Okay, here is example number 2 on solving these wave problems. We have a water wave travels at a speed of 5 meters per second with a frequency of 2 hertz. Determine the wavelength. So first thing, we can draw a little picture. Here's some water waves, so we got an idea of what we're looking at here. Second thing we want to write down are our given. So we read it through, 5 meters per second. And what's that? Well, that's our speed. So we'll put in a V for that. And we're also given frequency of 2 hertz. 2 hertz, which is 2/1 second. It's per second. And that is our frequency. And what are we looking for in this case? We're determining the wavelength. Anybody remember what the symbol for wavelength is? It's the Greek letter lambda, and it looks like that. So that's what I'm looking for. So again, I have a quick little picture. So we're looking at a wave here. We're given how fast the wave is going. The units are meters per second. We're told 2 hertz, which is 2 per second. It's kind of a weird unit there. That's the frequency. We're looking for the wavelength. So the next thing we do is we write down the equation that we're going to use. And in this case, we're using our relationship. Speed of a wave is frequency times wavelength, or I could have wavelength times frequency. Doesn't matter there. So now the next step, this is a common one people forget, is we want to rearrange this so we have what we're looking for all by itself. And we're looking for the wavelength. So I want wavelength by itself. So I'm going to divide both sides by frequency. So frequency would cancel there. And then I have my equation the way I want it. I have wavelength all by itself equals, speed is still on top, frequency is on the bottom. So now I want to check my units, because my unit should end up being, well, if I'm looking for a wavelength, it should just be in a unit of length, which is meters. So let's check. On top here, I have the velocity. So the units on velocity, meters per second. So I'm going to put meters per second. Okay. And then underneath it are my units for frequency. I can't use hertz here. I have to use per second. So 1 over seconds. So underneath, I'm going to write down here 1 over seconds. And then I notice that I have a second over a second. They cancel. So I'm left with meters. So my units check out. I'm good there. Now I can do my final step, which is just plugging in my numbers. So step 7 here, the wavelength equals, what do I have for my speed? 5 meters per second over the frequency, 2 over seconds. I know that's kind of weird, but now we already know the seconds are going to cancel. I'm left with meters, so I can get my answer here. 5 divided by 2 is 2.5 meters, and I get my answer. And now we're going to look at example number 3, and in this case, we have a guitar string. Plays a note, or a guitar plays a note with a wavelength of 0.71 meters. The speed of sound in air is 343 meters per second. That's actually at around 70 degrees Fahrenheit. We want you to determine the frequency of this note that's being played on the guitar. So we can draw a quick little picture like that. If you wanted to draw a guitar, you could. I'm no artist, but here's my guitar. And we've got a string here, and that string is vibrating. There's the whole guitar down like that. So I might draw a picture like that so I know what I'm talking about. That disturbance on the guitar string does produce a wave on the string, and it's transferred to the air. That's what we hear. So now let's look at our givens. So what are we given here? We're given 0.71 meters. Well, we're told it's the wavelength, and those are the units we're looking at. We're told the speed of sound in air, 343 meters per second, and that's the speed of the sound in the air, so we'll write that down. Then our next thing that we can put down is what the heck are we looking for in this problem, and we're looking for frequency. So we've got that set up. Now we go back to our equation. That's step 4. The equation we want, or the one we're using here, is the speed equals frequency times wavelength. And again, this is a step people forget. I want to rearrange this with the symbols first before I put in numbers. And I would like to rearrange this so frequency is by itself. So here I'm going to divide both sides by the wavelength. And notice wavelength cancels. So I get my equation now, which is frequency equals speed over wavelength. So that's good. Now to make sure that I set it up right, check the units. What unit did I have for velocity? I had meters over seconds. That's good. And then what unit did I have for wavelength? Well, that was just meters. So that goes on the bottom here. And then what cancels? Well, the meters cancel. So I'm left with essentially 1 over seconds. That is the unit for frequency. So I know I did it right. So then I can go to step 7 and just plug in my numbers using my correct equation. This step 6 checks your units to make sure you're doing things correctly. I know I'm right because the only thing I have left is seconds in the denominator. So now I can put in the numbers. 343 meters over seconds, and I'm going to divide that by the wavelength, 0.71 meters. And again, meters cancel. I'm left with something over seconds. Grab my calculator, and when I calculate this out, I get my answer here of something. I thought I had the answer here. I think it's around 483, and the units I have left are 1 over seconds. Or we could say, since 1 over seconds we know is hertz, 483 hertz.
So last but not least is example 4, which is Miss Nielsen is making transverse waves with a slinky. She measures the period of a wave to be 0.24 seconds and measures the wavelength to be 1.06 meters. What is the speed of this wave? So as usual, we're going to start with a sketch. Remember that transverse waves propagate perpendicular to the medium, so that means that they're going to make that traditional wave shape, and this is my poor attempt at drawing a slinky, but use your imagination of what that would look like. But that's my general sketch, so I can move on to givens and unknowns. So in the problem, the first number that I see is that the period of a wave is 0.24 seconds. And that corresponds again to the period of that wave. So I'm going to write that down. It's 0.24 seconds. That corresponds to the period. Remember, our symbol for period is capital T. Next up, I see that the wavelength, the measurement of the wavelength is 1.06 meters. That corresponds to the wavelength. So I'm going to write that number down, 1.06 meters. Again, it corresponds to the wavelength, and our symbol for wavelength is lambda. So now we can talk about unknowns. What is my unknown? Well, the question is asking me what is the speed of this wave. So I'm looking for wave speed, which is denoted as v. It's represented by v. What is v? That's what we're looking for. So next up, it's looking at equations. Well, there is no equation that will give me velocity from just period and wavelength. Usually I would use my first equation up there, but I don't have enough information if I want to find velocity. I would need to know, using that equation, I would need to know frequency and wavelength, and I don't know what frequency is. So frequency is actually one of my other unknowns that I'm going to have to find in order to find what wave speed is, right? So I'm going to have to find out what is frequency. Okay, I am given period in the problem, so that means I can use the period frequency relationship. So I'm going to try to find the frequency first before I tackle finding that wave speed. So I'm going to use the period frequency relationship, which states that frequency is the reciprocal of period. Then I'll be able to find out what my wave speed is, taking that frequency and multiplying it by wavelength. So it's actually more than one equation that's needed in this problem. It's kind of a two-parter. So we know that the units will work out for our velocity equation, our wave equation. We've proved that multiple times now, but let's take a look at the units for our frequency period relationship. So the units for frequency are hertz, and we want hertz to be equal to 1 divided by the unit for period, which is seconds. And we know that this is true. We know that a hertz is a 1 over second, and 1 over second is equal to 1 over second. So that's good. That's all going to work out for us. We checked our units. Now we can go ahead and solve for frequency. So again, I'm going to use my period frequency relationship. Frequency is going to be equal to 1 over the period, which in this problem is 0.24 seconds. So I'm going to plug that into my calculator on my phone, and when I do, I find out that the frequency of this wave is 4.17 hertz, or 1 over seconds. I'm going to use 1 over seconds instead, because that will just help me out with my wave equation. So the frequency is 4.17 1 over seconds. I did round up there, and we're using 1 over seconds instead of hertz. So now we can solve for our wave speed. What is v? Because remember, that was the goal of this problem. So remember, v is equal to frequency times wavelength. My frequency I just found was 4.17 1 over seconds, or 4.17 hertz, and I'm multiplying it by the wavelength given to me in the problem, which was 1.06 meters. So I'm going to plug that into my calculator. 4.17 times 1.06 will give me 4.42. And again, that's meters per second because a meter times a 1/2 is a meter per second. So that is our answer for example number 4.